If you're building on Azure, you'll eventually face this fork in the road. Do you write your infrastructure as code in Bicep, Microsoft's own domain-specific language, or in Terraform, HashiCorp's multi-cloud tool? Both deploy the same Azure resources, both are declarative, and both are mature in 2024. But they make very different trade-offs around state, multi-cloud, and day two operations. In the next 5 minutes, I'll break down where each one wins, where each one hurts, and give you a concrete rule of thumb for choosing. Start with the engine. Bicep is a thin abstraction over Azure Resource Manager, ARM. You write Bicep, the compiler transpiles it to an ARM template in JSON, and Resource Manager itself decides what to create, update, or delete. There's no separate state file. Terraform works differently. It talks to the Azure RM provider, which calls the same Azure APIs. But Terraform maintains its own state file that records what it believes exists. That state file is the source of truth for the plan, and it's the single biggest operational difference between the two. This is where architects argue most. With Bicep, Azure is the state. There's nothing to store, lock, or back up, and you can never have a stale state file. The downside is you only get incremental deployments and weaker drift detection out of the box. Terraform State gives you a precise plan, a real preview of changes, and rich drift detection, but you now own that file. You need a remote backend like an Azure storage account with blob locking. You must secure it because it can contain secrets, and concurrent runs need locking or they corrupt it. Scope matters. Bicep only targets Azure, full stop. Terraform speaks to thousands of providers, AWS, Google Cloud, Cloudflare, Datadog, Kubernetes, and more, all in one workflow with one state graph. If your platform spans multiple clouds or you provision SaaS alongside infrastructure, Terraform is the obvious fit. One nuance though, a Terraform configuration isn't magically portable. The Azure resources you declare are still Azure-specific. Multi-cloud means one tool and one language, not one set of resources you can move between clouds. Day-to-day authoring favors Bicep on Azure. It has a clean syntax, excellent Visual Studio Code tooling with type checking, and because it sits directly on Resource Manager, it usually supports brand new Azure resource types on launch day. Terraform's ARM provider sometimes lags behind by weeks for niche or preview features, though that gap is small for mainstream services. Terraform counters with a richer language, loops, conditionals, functions, and a huge module registry. Bicep has modules and loops too, but the ecosystem is smaller and Azure-centric. Think past the first deploy. With Terraform, the plan command gives reviewers a trustworthy diff in pull requests, and tools like TerraGrunt or Terraform Cloud handle environments and remote runs. The cost is state maintenance, drift reconciliation, and provider version pinning. With Bicep, there's less to operate. Deployments are idempotent through Resource Manager, and What If gives you a preview, though it's historically been less precise than Terraform's plan. For governance, Bicep pairs naturally with Azure Policy and deployment stacks. Both integrate cleanly with GitHub Actions or Azure DevOps pipelines. Here's my opinionated guidance. If you're Azure only, your team is Microsoft-centric, and you want minimal operational overhead, choose Bicep. It's free, first-party, and you'll never babysit a state file. If you run multiple clouds, provision SaaS, or your organization has already standardized on Terraform and HashiCorp configuration language skills, choose Terraform and invest in a locked remote backend. Don't pick based on syntax preference alone. Pick based on cloud scope and who operates it. And honestly, many large shops run both, Bicep for pure Azure platform teams and Terraform for cross-cloud. To recap, both deploy the same Azure resources, but Bicep leans on Resource Manager with no state file and same-day feature support, while Terraform owns its state, gives you precise plans, and reaches across many clouds. The deciding factors are cloud scope and operational ownership, not which syntax you like. Your action this week: take one small workload, write it in both, and run a deployment plus a deliberate config change to feel the difference in previews and drift handling. And because tooling and provider support move fast, verify current capabilities in the Azure and HashiCorp docs before you commit. If this helped, do me a favor, hit the like button, subscribe, and tap the bell so you don't miss the next one. See you in the next video.